Using CA enables us to reduce the time to develop parts, reduces the cost associated with development, and also, more importantly, reduces the number of physical prototypes we have to make to sign off a design phase.
One of the things we decided very early on is maneuverability of the vehicle. So the vehicle is very short. One of the main challenges from the crash structure point of view is we have a smaller crumple zone. And then one of the real big innovation we did is to be able to pack all the drive module and the motor in the package space and then use the drive module kinematics to be able to squeeze a lot of crush in that small space and then dissipate all the crash energy so that the occupants feel very low decelerations. I think it's probably industry first.
In the crash test event, we're not only looking at the event itself, we're also looking at what's happening after the crash. For example, if the vehicle gets into a crash, that we have the hazard lights switched on, that the occupant inside the vehicle sees where it is, that the lights are switched on. We want to make sure that we don't get potential hazardous fumes from the outside of the vehicle into the cabin, so we switch off the HVAC. And most important of all, we want to make sure that we get our occupants safely out of the vehicle. The overall concept and the idea that we have, that we want to build a safe vehicle and to protect riders as well as the people that are interact with our vehicle. A vehicle that is taking mobility to the next step and to a safer step.
Hi, I'm RJ, the Director of Perception at Zoox. Have you ever wondered how self-driving vehicles see and understand what is going on around them? That's what I'd like to share with you today. Just like human drivers, autonomous vehicles need to perceive their surroundings in order to navigate through the world. While you primarily rely on your eyes, Zoox robotaxis use a state-of-the-art combination of sensors strategically situated all around our vehicles. Each sensor type is complementary, and this combination provides our vehicles with the most accurate information about what is unfolding around them. Let's dive into how they work. Let's start with our cameras. They are unique in their ability to detect attributes like the color of traffic lights and even the facial expressions of pedestrians. But cameras are susceptible to severe weather conditions like heavy rain and snowstorms. They also cannot measure depth directly, and when things get really dark, it's harder to separate signal from noise. This is why relying solely on cameras for autonomous driving isn't the safest or most reliable approach. Next, we have LiDAR. LiDAR creates a 3D model of the surroundings. It fires millions of laser signals per second that reflect off objects and return to the sensor. LiDAR is great at detecting depth and measuring the shape and size of objects, no matter what they are, even if those objects have not been seen before. We also use radar. Radar works by bouncing radio waves off surfaces to determine the distance, size, speed, and direction of objects around the vehicle. Radar has 3 advantages. It provides velocity measurements with low latency, it detects agents at far distances, and it's robust in extreme weather conditions like rain, fog, and snow. Next, we have long-wave infrared sensors to detect objects based on their temperature. That enables our vehicles to more reliably detect objects that emit heat, such as people, vehicles, and animals, especially in low visibility conditions like at night. Finally, we have microphones that act as the ears of our vehicles. They are really valuable for detecting emergency vehicles, including where those vehicles are coming from. So as you can see, not all sensors are created equal. That's why we use sensor fusion to combine all the data. We accomplish this through a combination of state-of-the-art machine learning algorithms. These algorithms are trained and validated on both real-world and simulated driving miles. We have a test fleet of Toyota Highlanders that are currently driving autonomously in dense urban areas like San Francisco, Las Vegas, and Seattle. If you are in one of these cities, I hope you see one. We've built our vehicles from the ground up, and this gives us many advantages. Our sensor architecture consists of 4 identical sensor pods positioned high up on each of the 4 corners of the vehicle. Like everything on the Zoox Robotaxi, this sensor positioning is deliberate. It provides the vehicle with a 360-degree view of its surroundings, and because there's one on each corner, we have overlapping, redundant fields of view that enable the vehicle to see around things. That's what eliminates blind spots, and it allows our vehicle to view objects not just next to and behind it, but even objects behind other objects, which is especially important when navigating through busy streets. Our unique sensor configuration also ensures a full operational architecture